We're looking at differentiation part 1, higher maths revision for your prelim or for your final exam. We're going to cover question 5 here. This is the third video of 6 videos we're doing on this. So for differentiation we're going to go for question 5, and this question here is looking at finding the equation of the tangent to the curve. Okay, so here's the equation that I've got, and the point that I'm interested in is where x is equal to minus 1. Okay, so to do this here, when I see the equation of the tangent to the curve, I would expect that I'm going to differentiate that, and from there I'm going to find the gradient. Okay, so let's go ahead and start with part A. Right, I'm going to start with the equation of the curve. Okay, I'm going to differentiate it, so dy by dx, which also equals my gradient formula. So that's my gradient formula I'm going to get there. So differentiating, so 2 times the 3 gives me 6x to the power of 1, and that will be minus 2. So that's me got my gradient formula there. I want to know what the gradient is, so my gradient when x equals minus 1. So I'm just going to substitute a minus 1 in here. And what that will be is, that will be minus 6 minus 2 will give me minus 8. So that's minus 8. So that's my gradient that I'm going to use. Right, I also need a point of contact when I'm working out the equation of a tangent. So I just need gradient and also a point of contact. So to get the point of contact, this is the next bit, I'm going to find out my y coordinate when I know my x coordinate. So the thing I'm going to use is I'm going to use this equation here because it says y equals. So and I can find out what y equals when I know what x is. So that's what I'm going to use. So I'm going to use y equals 3x squared minus 2x. And what I'm going to do is I'm going to substitute a minus 1 in. So I'm going to substitute a minus 1 into the right hand side of this equation. That's just the instruction I'm given. So there's minus 1 going in there. I'm going to square it, and then 2 times the minus 1. Minus 1 squared is 1. 1 times 3 is going to be 3. And minus 2 times minus 1 will give me a plus 2. So that there is going to give me an answer of 5. So that's the y coordinate is going to be 5. So for there, the point of contact that I'm going to use is going to be minus 1 was the x coordinate I was asked to use, and 5 was the y coordinate I worked out. So now I've got a point and I've got the gradient. So what I'll do is I'll substitute the gradient equal minus 8 and the point of contact, which is minus 1, 5, into, and we'll just do that into the equation of a straight line. Okay, so remember to get that right. That's one that you really need to know. It crops up in many topics that we'll be doing at higher maths. Right, so let's substitute our numbers in. Okay, so that's my a value and that's my b value there, and there's m. Okay, so y minus 5 is equal to m is minus 8, and I've got x minus, and that's minus 1, so I'll just put that as a plus 1 there. Okay, what I'll do is I'll multiply the bracket out here. That'll be minus 8x, that'll be minus 8 there, and what I'll do is I'll just gather the x over to this side. So y plus 8x is equal to, take that 5 over to that side, that'll give me minus 3. Okay, so that there would be my final answer. Okay, that's the equation of the tangent to the curve when x equals minus 1. Right, for part B. Okay, a more complex equation that I've got here. Same type of format I'm going to follow. I'm going to differentiate, get my gradient, find my point of contact, substitute it into the equation of a straight line. Right, so let's go for that one. I'll write down the equation. Y is equal to 1 over x, and that's plus x. What I'll do is I'll have to prepare that, because I can't have x's on the bottom when I'm going to be differentiating. So that's going to be x to the minus 1 plus x. I'll now go ahead and differentiate. Remember, when I'm differentiating, I'm also finding a gradient formula. Okay, so minus 1 times the 1 that's at the front there, so that'll give me minus 1x to the power of minus 2, and then I've got x there, so that'll just give me 1 times 1, that'll just give me 1, and that'll be x to the power of 0, so I'm going to get just plus 1 coming out of there. Right, so the next thing I'm going to do is I'm going to substitute my value of a half into that equation there. That looks a bit awkward to deal with, so what I'm going to do is I'm going to put that back down to the bottom line. So what I'm going to say is that's going to be equal to minus 1 all over x squared. Okay, so all I'm doing is taking that part down to the denominator, and that will be plus 1. So that's something that I can work with a bit easier. So that's my gradient formula there. Okay, my gradient formula, or dy by dx. Right, so what I want to know is my gradient when I substitute in a half. So I've got minus 1 all over a half, and that's going to be squared, plus 1. That's going to be the same as minus 1. If I square a half, there's two ways I can do that. It's a half times a half, which will give me a quarter, or a half of a half is a quarter. Or what I can do is I can square the top, so that to square the top line, that's going to be 1. Square the bottom, 2 squared will be 4. So two different ways I can do that. And then I'm going to add on 1 at the end there. Now for this part here, there's different ways we can think about it. I'm going to do a little bit of working up the top here, just to let you see how we work that one out. I'll just do it in a different colour. Right, so what I've got there is minus 1 divided by 1 over 4, or by a quarter. So what I've got here is minus 1 divided by, and it's 1 quarter. So that's exactly the same as what that part there is. So that would be the same as minus 1, and I'm going to flip over that fraction, and I'm going to change the sign to a times. And then what I'll do is I'll just multiply straight across. So that's like minus 1 times 4, that will just give me minus 4. Or minus 4 over 1, which simplifies to minus 4. Okay, so that there was just to help you out if you struggle with some of the fraction work. Right, so from here, what I've got is, that bit there works out to me minus 4 plus 1, and that's going to give me an answer of minus 3 as my gradient. Right, so I'm going to find the point of contact next. So point of contact, so we're going to use y is equal to 1 over x plus x, and what I'm doing is I'm substituting in the value of a half into there. So it's 1 over a half plus a half. Right, so from there what I can do is I can just do the same as what I've done here. So that's going to be 1 times 2. Okay, so 1 times 2 is just going to give me 2. So that's going to be equal to 2 plus a half. And what I can do with that is just make it into a top heavy fraction. It's 2.5 is my answer, or it will be 5 over 2. Because 2 has 4 over 2, plus another one, 5 over 2. So there I've got my point of contact is equal to, so a half, 2 fractions, and the y coordinate is 5 over 2. I'm going to substitute the gradient that I worked out, which was minus 3, and the point of contact above, and I'm going to put that into y minus b equals mx minus a. Right, so let's go for it. So y minus 5 over 2 is equal to minus 3x minus, and it will be that value there, the half. Okay. What we'll then do is I'll multiply this out, and I'll try to sort it out a bit. Right, so let's just go for multiplying this side by minus 3 first of all. Minus 3x, and that will be plus 3 over 2 if I multiply minus 3 by minus a half. Okay, what I could then do is I'll bring that minus 5 over 2 over to this side, so I've got plus 3 over 2, and that's going to be plus 5 over 2, which will give me 8 over 2, so that there should give me an answer of y is equal to minus 3x, and that will be plus 4 when I gather that together there. Okay, so that should be my final answer. Okay, simplified. Right, so that's question 5. It's looking at the equation of a tangent to the curve. Sometimes the curve that you'll be working with will be a lot more complex than these ones here. Take care when you're doing it. Just try to work through the same steps as I have, and do your best with the equation of the tangent to the curve. Good luck.